In this video, I want to discuss the process planning of a part such as this lower gear housing shown here, which starts as a casting. So I have to decide what processes can be machined and in what machines to get it from the cast state to the finished state as shown here. So first I need to examine the final part print and examine the raw material. So the raw material comes in as a casting. And what I want to do is I want to machine the largest surface first. That'll give me the best location for the remaining operations. It's not always clear what the largest surface is. In some cases, it might be reasonable to machine this bore all the way through and use it for the primary datum and locate them. Or I might want to machine, if we go back to the finished part again, I might want to machine this face. This is the large surface area and the holes in it, and use these as my primary datums. So when thinking about this, I would analyze what's the surface area of this as well as this. Visually, we can see they're very close. They both would make good surfaces to start with. So to decide what I would do first, I'd have to look at the tolerance of this bore on the part. If it's a very tight tolerance, then that would be a great feature to machine first and use as my primary datum for all future location. Or if I look up here, I see I have two dowel holes, which also make great location for the remaining fixtures. So I can work from this large surface area, locating on these two dowel holes. I'll just go back to the isometric view. So either of those two options would be good. I've decided I'm going to go ahead and I'm going to machine this face first and these holes, and then use that for the location for the remaining operations. If the largest surface area isn't machined first, then any positional errors used for location in further setups will be amplified. So the next thing I want to do is say, okay, well, if I'm looking at the part this way, what features can be machined and should be machined in this setup? So I'm going to click on this configuration and make it active. And all these features shown in red could be machined in a typical vertical 3-axis milling machine. Let's go back to the isometric view. As to the types of machines I would use, that would depend on what we have available, where it's being manufactured. These two faces could be machined in a manual vertical mill. I could also make a fixture for a horizontal mill. And then the holes could be drilled in a drill jig later, as well as these spot faced in a drill jig. Or I could put it on a CNC machine and machine these two surfaces, machine all holes, and spot face these 4 holes. And for my facility, I'm going to design a fixture that will hold it for a 3-axis vertical CNC mill. Now that I've established the primary datum, I can use this face as my 3-point location and these 2 dowel holes as concentric locators for the remaining fixtures, so that I'm always using the same surfaces and datums to locate every other machining feature. So now that I've decided on op 10, again I have to say, well, what should be machined next? So in this case, I've decided I'll build a fixture for another vertical 3-axis mill, where this is now facing up, and I can machine these faces and this bore and these half bores. And then I will go on to after that, I want to ask myself, have I machined everything this machine can reach? If I have, that's great. I need to process the next plan. So then I've decided I'll turn it around, and this will now be facing the machine spindle on my vertical 3-axis mill. And I can machine these faces, this bore, the holes, and these bores. And then the last thing I need to do is, once again, I'm going to design something for another 3-axis vertical mill, and I'll machine these 3 faces and add all of these holes, and now my part has been machined to completeness in 4 operations.